the way we describe the structure of a sentence is using a syntax tree. So let's work on a sentence that only contains one word over and over. Buffalo are beasts that live in Africa. That's a noun. They look like this. Buffalo also is a verb. And so buffalo means to intimidate, which is something that buffalo do. Now you might wonder, what do these buffalo out there in Africa? Well, there isn't much to intimidate. Mostly they just buffalo other buffalo. So here we have a sentence where the subject noun phrase is these buffalo. And the verb phrase is that they buffalo other buffalo. The verb phrase also has structure, so it consists of a verb and then a noun phrase, the buffalo that are being buffaloed. Now we'd like to be able to represent this structure in our Python program. So we're going to use two different classes. A tree class represents a whole phrase, such as this sentence or this verb phrase. It has a tag that tells you what kind of phrase it is. And we'll use just the first letters, so S or NP, in order to represent sentences and noun phrases. We also have a sequence of branches, and so that's why we form syntax trees. So these are a sequence of tree or leaf components that make up the tree. A leaf represents a single word. So you have a tag for that word that tells you its syntactic category, N or V for noun or verb, and then you have the word itself. So there's a leaf, there's a tree, there's a leaf, there's another leaf, there's another tree, there's another tree, and the whole thing is a tree. So what's the equivalent Python? Well, I could create a leaf for the noun phrase buffalo. We'll call that beasts, just to keep track of which buffalo it is. And intimidate is the verb, whereas beasts is the noun. So beasts intimidate beasts would be created by having the symbols S, NP, and VP just bound to the equivalent strings, and then building a tree, where the tree has tag S and has branches, which are the subject noun phrase and the verb phrase. The verb phrase has two branches itself, one of which is a leaf, the intimidate leaf, and the other of which is a tree containing the leaf for the buffalo at the end. So here we have buffalo, 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 and we've encoded the tree structure that you see above. So the Python code that's required in order to support this representation is fairly straightforward. I have a tree class and a leaf class. The tree takes a tag and some branches, checks to make sure that the branches are all trees or leaves, and stores them. A leaf just takes a tag and a word and stores those. And here you see the code from the slide. So if I load this file and take a look at S, it's a tree object which has a tag S. And if we look at its branches and look at the first branch, what's its tag? That would be the NP. And the branch at index 1 has tag VP. Now, it's hard to explore a tree in this way, so we also have a file called printTree, which can take in a tree and print it out in a useful way. So now we can see the whole structure at once. And printTree is just a recursive function that prints leaves, and for trees, it prints an open parenthesis, then a tag, and then it prints all the branches.